Okay, welcome to back to Math Boot Camp. My name is Loy Gross from the Learning Center at Genesee Community College. And in this particular segment, we're going to cover prime numbers and prime factorization. When are you going to use prime numbers? We're going to use prime numbers all over the place. Prime numbers are the smallest numbers that we can break other numbers down into. And when we break things down into their smallest parts, we find that we can do very, very useful things with them. It also helps us understand a little bit about how numbers work and how multiplication and division work. It's kind of a tool. If divisibility rules are a hammer, prime factorization is a wrench. You're going to put this tool in your math toolkit and you're going to pull it out whenever the job calls for it. Let's talk about prime numbers versus composite numbers. Prime numbers are numbers that are only divisible by themselves in one. So can you think of a number that you can only divide evenly by itself? How about 7? Can I divide 7 evenly by 2? No. By 3? No. By 4? No. 7 is only divisible by 7 and 1. So that makes it a prime number. Composite numbers are sort of the opposite. Composite numbers are divisible by other numbers. So can you think of a number that's divisible by another smaller number? Let's say, for example, the number 8. We can divide that by 2. We can divide that by 4. So 8 is a composite number. So on the left here, we've got some prime numbers. They've got little blue dots. And on the right, we've got some composite numbers, little red dots. Let's take that 7 in our example. Our 7 here. If I tried to rearrange these dots and stack them in a bunch of even rows and have them stacked nice and neatly, could I do that without having one dot left over? And no, I couldn't. So 7 is only divisible by 7 and 1. 8 over here, divisible by 4. We can make 4 stacks of 2. We can make 2 stacks of 4. Over here, 9. 9 is divisible by 3. We can make 3 stacks of 3 very neatly. So those are composite numbers, and composite numbers are, quite frankly, most of the numbers that we work with. Let's talk a little bit about prime factorization. Prime factorization is breaking a number down into its prime factors. So for example, 72 can be broken down into 9 times 8. That's awesome. That's 72. But 9 and 8 are not prime numbers. So we have to break them both down again. 9 breaks down into 3 and 3. 8 breaks into 2 and 4. Oh wait, 4 is not a prime number. We have to break 4 down into 2 and 2. Now we have our answer. 72 is 3 times 3 times 2 times 2 times 2. And if we do all those multiplications, we're going to get 72. So there are lots of different ways to do prime factorization. Many students were taught the tree method. That's over here on the left. If you have a method that you like, you go for it and you do it. In this video, I'm going to show you the birthday cake method, which is pictured over on the right. It's called the birthday cake method because it ends up looking like a birthday cake. You notice they both get the same answer. The tree method might be a little bit harder to read, but it's the same answer. You got a 3, 2, 2, 2, 2, 3, 5. Over here we have 2, 2, 2, 2, 2, 3, 3, 5. The birthday cake method, and the reason that I like the birthday cake method, is that you'll know for certain when you're done. You won't have to wonder, do I have to break any of these down any further? Nope. When you get to the top, you're done. So let's talk about the birthday cake method. To use this method, we start at the bottom of our paper and we use something called short division. And short division is just division without any remainders. So here I have a number 1125, and I'm going to break that down into its prime factors. Here is the key question that drives the birthday cake method. What is the smallest number that will divide evenly into my 1125? And the smallest number that will divide into 1125 is not 5. We know 5 will divide into it. But if we remember our divisibility rules, we can see that 3 will also divide into there. 3 will go into 11 3 times. That's 9. Remainder 2. If I take the 2, 3 goes into 22 7 times. That's 21. Carry the 1. 3 goes into 15 5 times. And there's my next layer of my cake. Since this is not a prime number, I'm going to continue. What's the smallest number that will divide into 375? Well, guess what? It's 3 again. So 3 will go to 375, 3 into 3 once, 3 into 7 two times, that's 6. Carry the 1, 3 into 15 five times. Now I have a 125 and my next layer on my cake. And I just keep going. Smallest number here is 5. We'll go into 12 two times, carry the 2, and that gives me 25. How many times? What is the smallest number that will go into 25? Is 5, and that will go in 5 times. What's the smallest number will divide into the number 5? Well, that's 5 because 5 is a prime, and that goes in just once. And there's the candle on the top of my birthday cake, and I have finished my birthday cake. So the prime factorization of 1125 is 3 times 3 times 5 times 5 times 5. And that's the birthday cake method of prime factorization. Try it yourself on a few sample problems until you've got it down.